We're looking at a historic, unprecedented severe weather risk happening today across parts of the Midwest. Moderate risk, the first ever in this region in December, issued by the Storm Prediction Center across much of Iowa and into parts of Minnesota. And in this video here, we're looking at the characteristics of this environment which could lead to this potential derecho and possibly even tornado outbreak. And we're starting with the 500 millibar charts vorticity because we note already in this a very strong vortmax and negatively tilted trough right here over Colorado. And as we head through the day into the afternoon, that's going to be progressing rapidly into the Central Plains to whereby 00Z, the absolute vorticity maximum, is already coming into Iowa. Very negative, very dynamic upper level trough right here, extremely strong. And you could actually already see that on the current Meso analysis right here, where the blue areas show positive vorticity advection, the red areas show negative vorticity advection, and this is very quickly ejecting with strong upper level dynamics into the Central Plains toward the Midwest. And what that's going to lead to is rapid surface low deepening. We see right here earlier in the day, this low is going to already be 990 or 988 millibars. By 00Z, it's to 984, and by 06Z in Minnesota, 980 millibars. Very strong low pressure right through here, and obviously the pressure falls generated will cause strong moisture advection in the warm sector, coming right up in here to the south of the warm front and to the east of this strong advancing cold front associated with it. So we got surface dew points into central Iowa in this mid-December, coming up into the mid-60s with temperatures in the 70s. And in addition to that, we have mid-level lapse rates that are steepening, because as we show this animation here, we see what is a very pronounced EML right through here, elevated mixed layer, steepening the lapse rates, adding them some dry air. It will add some inhibition right through the core of it mainly, but as we head through the day, extremely strong upper level ascent will tend to erode that completely, and it will reach the point where it's no longer really an issue for us regarding convection and potential for severe weather. And what that's going to lead to, those combinations of thermodynamics should be appreciable low-level CAPE. Values right in through here could potentially reach 1,000 to 1,250 joules per kilogram, perhaps a little bit higher. Pretty much uncapped too, as we have this upper level system coming in. And what that's leading to is very strong potential for thunderstorms in an extremely strong sheared environment. Because if we're looking aloft at 500 millibars, we would see very strong upper level flow with that vortmax as it approaches right here, the base of the shortwave, ejecting in this region. A very potent 500 millibar speed max is going to push right in through here at the very base of that negatively tilted wave, to where it places it right over this part of Iowa by late afternoon, early evening. So very strong vertical wind shear is likely. We look at the effective bulk shear on this particular map, and we see extreme values of this coming in through here. These are 70 plus knots, in some cases 80 plus knots. 0 to 6 kilometer shear might end up being toward 90 knots in this region, because we have such incredibly strong mid-level flow pushing right into this area. And in addition to that, very strong low-level flow. Let's zoom in a little bit. Very strong low-level flow. 850 millibar winds in association with this amplifying low could reach 70 to 80 knots. And this is southwesterly, but still leading to elongated totograph structures and very strong low-level shear. Because we're going to be heading through the evening right here, we see by late afternoon 22Z already 0 to 1 kilometer SRH in this region from Iowa into parts of Kansas and Missouri, also into Nebraska. Already seeing values over 300 meters squared per second squared. But as we head toward the evening, it gets even larger. There it is still. And very strong values also spreading up into Minnesota. I think they'll be higher than 200 actually up here. And what that's going to promote is low-level mesocyclone development, particularly since we have very strong low-level wind shear and also a degree of boundary crossing 0 to 6 kilometer bulk shear vectors. So that's, even though we have a primarily linear mode, we are going to have embedded supercells. and embedded line of wave patterns. That will increase the potential for severe weather, including destructive winds, tornadoes, perhaps even some strong tornadoes. And to get an idea of the environment that's going to be a result of this, let's take a forecast sounding from the NAM model. And a number of concerning things are noted here. The Cape profile is really actually quite large for the time of year. It's uncapped also, and low or high relative humidity in the boundary layer we see right through here. So cloud bases are quite low, as noted over here. LCL, LFC heights are low. Obviously the vertical wind shear is extremely strong. This box down here, 80 plus knots on everything. 0 to 1 kilometer SRH is over, it's approaching 400 in this case, and that would not be surprising to see instances where we have that. Strong turning of the flow too as we head aloft. It's a little bit southerly of a component in this particular wind profile, as we see right through here. So that could increase the curvature even more, to where we see up here in the upper right corner, very, very large photograph curvature, very fast storm motions, and as you see there, it warrants a PDS tornado sounding. And with that, we have very high composite parameters down here in this box. STP, potentially 3 to 4. And we do have a primarily linear mode, but we're still going to be seeing tornado potential with this. So, heading in through the short term, because this is going to be happening over the next several hours, we start to see stuff developing and organizing over parts of Kansas and Nebraska. Then it becomes very intense, and these are in increments of 1 hour. So this is really fast moving. We already see some embedded supercells there, embedded supercells quite visible in this particular frame right here, and a very extensive band of thunderstorms. Intense thunderstorms are spreading into western parts of Iowa at this point, and also parts of northern Missouri. They could get in on some of this too, although it will start to wane in Missouri as time goes along. And then we head through the evening, still supercells, intense wind damage spreading throughout Iowa. The line will start to weaken as it approaches Illinois, but still looking at severe weather potential going on into southern, maybe central parts of Minnesota, throughout parts of Wisconsin too, where we could see widespread wind damage and some intense tornadoes, several tornadoes perhaps. This area right here under the moderate risk, this is where things look to be most volatile as we head into the evening, with that potential derecho event. In this area, wind speeds will likely be 60, 70, even 80 miles an hour, and some gusts, particularly with the more organized convective segments, could potentially be 100 miles per hour. And we could see several fast-moving, rapidly developing strong tornadoes. So that is a risk evaluation for December 15th, 2021 on this unprecedented moderate risk, just so soon after the historic tornado that ripped through Kentucky on December 10th and 11th.